take a look at a food group that we don't always think about, the greens. Incredibly nutritious component of the diet. When we think about food groups, in other words, nutrition on the bigger scale, we often are talking about micronutrients and stuff, and we'll talk about those somewhat today as well, but we often need to step back and look at the bigger picture. What is it we eat? And when I was growing up, and some of you are similar age may have learned the same four basic food groups, right? There was the meat groups, the dairy groups, the grains, the fruits and veggies, and in an Adventist home, we sort of had our own version. We had, some eggs here, and we, had the Loma Linda, Worthington veggie meats that sort of we put in here, and the milk and cheese, the grains. So we had our four food groups as well. And throughout my entire educational career, this was the official government position right here. Kind of feel bad for the cows. They make up two of the four food groups. But did you know that wasn't the first one? Before there was the four food groups, anybody know what we had? There were the 7 food groups. Yeah, during World War II, the government became concerned about the nutritional status of the citizens with all the food rationing and everything, and wanted to make sure that people weren't skimping and becoming malnourished, and so they created the 7 food groups, and this was quite well published during World War II. They had the green and yellow vegetables, which meant certain nutrients. They had the orange, tomatoes, and grapefruit food group. That was sort of like, I think, vitamin C they were thinking of there. And they had potatoes and other vegetables and fruits in a group over here. And then they had the dairy products, the meat products, the grain products. And butter and margarine had their own food group here as well. And then after you ate of all 7 of those food groups, in addition to the basic 7, eat anything else you want. So that was the original government attempt to advise us in our thing. But the 4 food groups were used up clear through my educational time, clear through medical school. It wasn't till 1992 that some of the science of nutrition sunk in enough that they realized these 4 food groups doesn't quite cut it here. And they came up with the food pyramid. And now we've got the base of the pyramid here with your grains. All of their important nutrients and carbohydrates made up the base. Fruits and vegetables on top of that. And we've got the bulk of the diet already done right here. Makes a lot more nutritional sense that way, doesn't it? And then meat and dairy product is relegated to a more minor, later addition to the diet here. And you'll notice when they added the meat here, now they've mentioned dry beans and nuts as part of this group. They've recognized that, you don't have to eat meat. You can have beans and nuts right here to take care of the nutrients from this group here. And then, of course, they added this little cap on the pyramid here, but they pointed out, use sparingly the fats, oils, and sweets. Now, the meat and dairy lobbies did not take too kindly to this because it sort of relegated them to a minor position and not more basic. And after some degree of lobbying, they actually got us to revise the pyramid. In 2005, they now published the revised pyramid. And now instead of hierarchical levels here, everything is moved down to the base, and there's different shaped wedges here on the pyramid. There's still a little skinny wedge here for refined oils, but you notice that dairy and meat products are now part of the base of the pyramid here, one of the food groups that is needed here. You can see they've still got pictures of nuts and beans and stuff added with the meat group, and they've even labeled here, meat and beans. So we've made some progress there. And then they added steps on the side of the pyramid here, because they're recognizing, we need to do exercise as well as eat. And I've seen versions that also had a big glass of water over here on this side of the pyramid here. And so this has been our pyramid here from 2005 up until just a few years ago. They came up with the full plate And now they've got this plate divided in portions right here, recognizing vegetables should be a large part of the diet, fruit should be a large part of the diet, grains. Notice they call it protein now instead of a meat group right here, recognizing you really don't have to have meat. And of course, dairy couldn't be left out. They got at least added on the side here. Some of you may be familiar with Neil Bernard and the Physicians Committee for Responsible Medicine. Their website has excellent nutritional and menu data and stuff. If you ever want a website for yourself or to refer people to, PCRM's got excellent stuff. And they gave their version of the plate. They've got fruits here, pretty good sized serving of vegetables here, really enlarged the serving of grains. And you notice they made sure they were whole grains on theirs. You know, we have so many of our grains today are in forms of flours and pastas and stuff that are white, refined, where they've taken much of the nutrients out. And of course, for their protein version, they've specified legumes here, and then again, relegating it to probably a more appropriate, smaller sized version here. Now, if we were to ask a group of health reforming, conservative Seventh-day Adventists, what are the ideal food groups, what answer would we get? Well, most would talk about, well, the Eden diet. Yes, we're going back to the Eden diet. Fruits and vegetables and, all this stuff there. God says, look, I've given you all these trees and their nuts and seeds and fruits. The herb-bearing seed, that's all the grains, your quinoa, your flax, your wheat, your barley, all of those type of things. So all of these various fruits and seeds make up the ideal diet given to us by God. And again, that's going to be our ideal diet throughout eternity, and it's certainly a good place to look for our food today. But I'd like us to now look at that other food group that God added. And we're going to focus our time, the rest of this lecture and our next lecture, in taking a closer look at this additional food group. After the fall, Adam and Eve were driven out of the garden. At that very point, God said something, and he brought something to their attention. And I think, like most of the other statements, it's like almost every phrase of it has deep meaning if you analyze it. I'm sure Pastor Bohr would agree with that. But when we look at what he told them, we're told that the ground was cursed for man's sake. And of course, I always kind of read that as, yes, you deserved it. You're going to get a spanking now. We're going to make the earth a more miserable place for you to live. And I suppose there's some truth to that. Spankings do help us to grow up and to learn some lessons. But that phrase, he cursed the ground for man's sake could just as easily and probably maybe more appropriately in a deeper sense be for man's benefit. He cursed the ground for our benefit. And by the sweat of your brow, you're going to earn your bread. And throughout our last few thousand years here in this sin-marred world, hard labor has been a benefit to man. You look at individuals, you look at civilizations. It was the hard-working civilizations, the hard-working individuals that accomplished something, that made something of their lives. We look at some of the more wicked civilizations, we see them described as full of bread and idleness. And of course, America today could well fit in that category. Certainly, today you can be as lazy and unproductive you want, and you'll still be full of bread and a lot of other junk food along with it. But God gave that hard work for our benefit, not only the physical labor, but mentally occupying the mind and accomplishing useful work. When Jesus came here, he was appointed a life as a peasant and a humble as a carpenter, and worked and placed his blessing upon this, what they intended here. But in addition to that, he said, thorns and thistles shall it bring forth to thee. And there is educational blessings we can gain from thorns and thistles. Before they left the Eden, God sacrificed the lamb and gave them lessons about his love, about the plan of salvation, the plan of forgiveness, of restoration. But as they went out into the world full of sin, the thorns and thistles would also teach them lessons about sanctification. As you weed your garden, there's a lot to be learning about weeding the character from the results of sin in it here. A lot to be learned for raising children from there. And then he added that phrase that I want to spend our time on here, and you shall eat the herb of the field. You know, before that, their diet had been the fruits. And when he mentioned the herbs, it was the herbs bearing seed. It was all of the grains and seeds and that type of thing. But now he's talking about eating the herb of the field. Initially, that was designated for the animal kingdom. The animals were to eat the greens, and you have the fruits and seeds. But now he's saying, you're going to eat these greens too. And it wasn't a punishment. Now you've got to eat your spinach. It was a blessing. There was something in there, an intense nutritional value that goes far beyond the simplicity of the various nutrients that were found in fruits and vegetables. And I'm going to take a look at those here. You know, God understands our needs. He gave us that. And Ellen White recognizes that not only did he give us that original Eden diet, but he also was given the permission to eat these herbs in the field. And they're going to impart a strength, a power of endurance, a vigor and intellect that are not affordable by a more complex and stimulating diet. Including the greens in the diet is going to include a huge additional nutritional benefit. There was another time when God changed the diet. When Noah came out of the ark, the world was vastly different than when he went in. And in that barren world that now faced him, he thought he had to earn his bread by the sweat of his brow before. Now he could sweat his brow as much as he wanted and probably still starve in most places because it was such a barren, desolate place. But in that world, a goat can climb on a hillside with a few weeds and cactus and yet can gain the nutrition concentrated in its body. And Noah could eat the goat and still get the benefit he needed. It's sort of like God saying, you know, before, you know, things were bad, but now it's like, whatever it takes, go ahead and do it. You know, we want you to get the nutrition you need to stay alive. And then he adds that very interesting phrase and sentence again, when he said, every living thing that lives shall be food for you. As I gave you the green plants, so now I give you everything. So he points them back. At this point in history, he points them back to that time when they left the garden. Said, remember when I gave you the green plants to eat as well? Well, now things are really bad. You eat whatever you have to eat to make it go right here. So again, at this point, it confirms that addition of the greens to man's diet at the time he left Eden, at the time of his fall. And of course, as man lives in this desolate world today, many times the greens provide nutrients for us as well as for the cattle here. There are times and cultures when meat eating is probably still essential to get the nutrients that people need. Here in the United States today, we have that abundance of fruit that we can probably get whatever we want without touching the animal products, much to our benefit. But the greens still are there for us. It causes the grass to grow for the cattle, and the herb for the service of man, that he may bring forth food out of the earth. Have you ever grown greens in your garden? They're really easy to grow compared to other stuff, right? It doesn't take the same master gardening skills to grow tomatoes, eggplants, and stuff. For greens, you plant the seeds, they grow. You plant them in the shade, they grow. I mean, all kinds of things would make it more difficult to farm the various fruits and vegetables. The greens will grow, and you get the tremendous amount of nutrients, and very rapidly. This summer, as I became more convinced of the values of greens and started deciding to add some green smoothies to my diet on a regular basis, I started realizing I was going to the store very frequently and the food wasn't as fresh as I would like it to be. And so I said, I've got to get out and plant a garden in my backyard. It had been neglected, I'd been busy and hadn't really started a garden that year. And so I went out and started planting greens. Within a few weeks, these are pictures of my garden right here. The greens are just growing. And they're growing where there's a tree that shades it most of the day. And within a few weeks after that, you can begin to keep up with the greens that they grow. A tremendous amount of food can be brought forth from the ground when we're looking at greens as the source of that food. Red Russian kale. How many of you know what red Russian kale is? It's one of my favorites. It's very sweet, tender flavor. You steam up a pan of red Russian kale, really good. In old Russia, it was known as hunger gap kale. When they lived more in the cycle of the seasons, as they have throughout much of Earth's history, during the summer you had an abundance, and in the fall you put aside the stuff. And then the winter you ate the potatoes and apples out of the cellar, and the sauerkraut that had been canned and put away there, and a few other pickled things. But by the end of winter, most of those supplies were running out. And as soon as it was enough thaw that you could plant or get anything started growing, well, it's still going to be months until you can start harvesting tomatoes and cucumbers and get your new harvest going. But the greens, these greens, they sprout, they grow very well in the cool, cold weather, and are full of nutrients and nutrition. And the Russian people there, in the early spring months until their summer stuff would come in, lived on hunger gap kale, supplying that gap in their nutritional cycle of the year. A good thing for us to remember as we look at what's coming upon the world, not only a time where can't buy and sell, but a time when calamities and weather changes are, the difficulty and security of the food supply becomes more and more tenuous. And as we look at, coming to God to supply our needs, realize that many of those needs have already been supplied right here in the greens that he asks us to eat. They're right there. He says they grow easy. Just plant them out there. They'll grow in almost any weather and any condition, and they're really good for you. You're going to be able to get by. You're going to get a tremendous amount here. Don't forget the greens. And even in some vital nutrients, these cows here, you don't have to eat meat to get your protein. We don't. Is there protein in greens? How much protein can you get out of greens? Well, let's just take a look at the nutrient density. Let's compare some beef here. 9.4 grams per 100 calories in the beef. And let's compare a green, one of the greens that most people would put on their favorite list, kind of ahead of spinach and kale there. What's it got? 11.1 grams per 100 calories. Now, which is actually the better source of protein, beef or broccoli? Yeah, the greens are really an advanced source of protein here. And as any cow will tell you, you can get everything you need to make protein out of greens. And by the way, you won't get mad cow disease from broccoli or many of the other cancers of this generation here, you won't find over here in the broccoli. As a matter of fact, what they're finding in broccoli is there is compounds in there that prevent cancer. And now they're finding they not only prevent cancer, they can take people with cancer and start putting them high doses of broccoli and kale and cabbage. And guess what? Some cancers will reverse and go away with those by just putting the proper nutrients in there. So, we definitely have an advantage here. And it's a lot easier to grow broccoli than to raise a cow. We're trying here. Take a look at the essential amino acid profile here. And I promised, I don't normally make these, PowerPoint type slide programs. I always just like to draw a picture up here and illustrate it. And decided I'd make this. I promised I wouldn't make any busy slides with a lot of data on them. But there's two in this lecture, none in the second lecture. So bear with it right here. And you actually don't need to read all the points. it's just to get you the overall idea. On this side right here are the essential amino acids. These are amino acids that your body does not make. You need to have these in your diet. In other words, you have to eat a food source that has these 9 essential amino acids in it. Then from these, your body will make all of the other amino acids that it needs. But you have to bring these in the diet here. And here in the first column, we have the recommended daily allowance. Various scientists have figured this is sort of the recommended amount we should eat every day. And then here we've got kale up here, and then kale over here, lamb's quarters here for these 2 columns. How many of you know what lamb's quarters is? It's a weed, right? Well, we call it a weed today because we don't grow it commercially, but steam up a plate of that and try it compared to a plate of spinach. It's delicious, and it's free. It's a weed. Most people are throwing it away. It's growing everywhere. Rid of it. But some amazing stuff that just God made sure these nutritious foods are freely and readily available for the animals and for us. But look at these numbers in these columns right here compared to the recommended daily allowance. I mean, can you get what you need from greens? Oh, absolutely. They are excellent sources. Excellent food right here in terms of the protein. Now, I don't know how far we should take this illustration, but a lot of people, when they talk about greens, talk about the chimpanzees and the chimpanzee diet and point out, you know, if you look at the DNA of a chimpanzee and a human, there's only 4% different DNA that we have that chimpanzees don't have. Some people have a different way of actually looking at the percentage where they don't count certain duplicators. They come up with 99.4% that's similar. But even we take this number, we want to be a little different than the chimpanzees here. 96% without question, their chromosomes, their DNAs, the enzyme systems they make, the structural proteins they make, are all coded exactly identical. Well, if that much of the physiology is the same, would there be some dietary advice or wisdom we could learn from the chimpanzee's diet? What do chimpanzees eat in the wild? Well, about half of their diet is fruits and vegetables. And about almost as much is greens, green leaves. By the way, when I use the term vegetables, I'm using it in terms of fruit vegetables, like squash and tomatoes and where we're eating the fruit part of the plant. And when I'm using the term greens, we're talking about the leaves of the plant here. And a certain amount of their diet is just stems. I don't know if we'd want to include that. And a very small percent is insects. So they got a little bit of animal protein in their diet here. If you look at the typical standard American diet, this large percentage here is grains. We eat a huge amount of grain here. Some fruits and vegetables, quite a bit of animal protein in the diet, a lot of refined oils and stuff here, which of course the chimpanzees don't have. And then how much greens do we get? Barely a minute fraction of the standard American diet is greens there. Of course, the chimpanzees are actually in quite good health with their diet, and the standard American diet today is bringing what level of disease upon us in this country? I mean, it's like everybody's sick by a certain age. It's hard to find anybody that doesn't have something wrong with them. Yeah, system is breaking down on this diet. Chimpanzees are doing pretty good on this diet. There might be something we could learn there. Now, I'd like us to take a look and compare greens to the fruits and vegetables here. And just as an example, here's some beets we pull out of the garden right here. Now, in the case of beets, the fruit is actually the root. And then there's the stems, and then here's the leaves up here. And in 2 columns here, this first column that says beets is the nutritional contents of a number of nutrients as found in the beet roots. And the second column here, beet greens, is what we're finding up here in the leaves of the beet. And then over here, I just show the percentage of that it's more in the leaves right here. So example, protein. There's 138% more protein in the leaves of a beet than there are in the root of the beet. The one place where the root wins out is sugar. Well, I mean, if you think about that, makes sense. What are the leaves doing? They're making sugar, they send them down to the stems, they store them in the root. And so when we eat the beet roots, we're getting all of the energy that the plant has stored down there. The same is true in a peach. All the peach leaves send it through the stems and branches and puts it in the peach fruit. And so we get the sugars in there, we get a concentrated source of energy. And by the way, as we're talking about greens, don't get overbalanced inside and say, oh no, we don't need to eat fruits and vegetables. I'm talking about adding that as an essential food group, not replacing all of the essential food groups here. So yeah, we'll eat the beets, but don't throw away the greens. I mean, how many times we get the beets, throw away the greens? We get the carrots, we throw away the tops. The turnips, we throw away the top. We're throwing away the greens, and where's most of the nutrition? In the greens. I mean, look at the calcium. 731% more calcium in the leaves than in the fruit. Look at iron, 321% more. Magnesium, 300% more. Potassium, 234% more. We always said, what's a good source of potassium? Well, Orbury says bananas, oranges. Don't forget your greens. Your greens are full of potassium. Yeah, spinach is a great source of potassium. And by the way, these green numbers that we're putting here for beets are very, very similar for every green leaf. Green leaves have a lot in common with each other. They all have the same job, to use sunlight and make energy for the plant. And they all have similar composition and similar type numbers here. Here's copper, 200%. Vitamin C, 600% more vitamin C in the leaves than in the fruit. Thiamine, 300% more. Riboflavin, 550% more. Vitamin A, wow, 19,000%. I mean, it's just huge. I mean, what is it here? 33 milligrams there in the beet and 6,326 milligrams in the greens right here, vitamin A. Vitamin E, 3,700%. And vitamin K, I mean, 200,000%. You wrap your mind around that? Yeah, it's really a huge amount. This evening we're going to talk about vitamin K and why it's so essential right here. But the rest of this morning I want to talk about chlorophyll. Chlorophyll is why plants are green. Anywhere there's life thriving in this world today, what color is it? The mountains are green, the prairies are green, the rainforests are green. There's green everywhere. And the green is due to a molecule called chlorophyll in these leaves. If you looked at the leaves under the microscope, here at the top here, you see these large hexagonal structures are actually the plant cells. And inside the plant cell, there's little organelles called chloroplasts. And if you took one of these chloroplasts and looked at it under an even more powerful microscope, you find that it's organized in little disc-shaped membranous structures there. And even there, the chlorophyll just isn't in chlorophyll soup. It's all organized and lined up. And chlorophyll is only one part of a complex mechanism with lots of different proteins and other important molecules for absorbing and passing on energy and converting it into chemical energy that the plant can then store and use for the energy of its needs and store and again make energy for you. But all of these complex little thing right there, chlorophyll is that first step. This chlorophyll molecule here, it's a large, large molecule, very symmetrical, very similar to a hemoglobin molecule in its structure. Of course, hemoglobin has iron at the middle of it, and its job is to carry oxygen for us, a very different job. But God uses the same kind of structure to hold that magnesium right in place there, and the magnesium catches that photon of sunlight energy as it strikes there. It actually absorbs that energy from that and passes it on down the chain to the next molecule, which passes it to the next molecule, to the next, and through this complex set of little proteins that move it around, and you end up with a constant electrical current. As long as the light is shining on there, it's continued to pass these electrons down, make up that voltage thing across the membranes of these little thylakoids, which are the little teeny things inside the chloroplast. They're continually have, with this voltage across there, are continually converting sunlight energy into chemical bonds, high-energy chemical bonds in ATP, adenosine, which is then used to build glucose, to build amino acids. And all of these nutrients that we look for in foods are built based on this energy right here. This little picture up here is this light spectrum, the different frequencies of light. And these two lines, the black and the white, is chlorophyll A and chlorophyll B. There's several different forms of chlorophyll that are used a little bit differently in this photosynthesis reaction. And so they absorb all this purple and blue light, and they also absorb red light over here. Now, if you add to this spectrum beta-carotene and leucopene and a number of other pigmented molecules that are part of this same photosynthetic chain right here, you'll find that they absorb right here in this range right here. And so when you add those molecules together with these, what is left? The green. The green is the one wavelengths here that are not absorbed. And so any light that shines through here, all of the blue and purples and reds are absorbed, and what's left? The green. So you hold a leaf up to the light, and you get green light shining through. If light shines on it and reflects off, what reflects off? Green light. And that's why plants are green, all right down to this hemoglobin molecule there. And of course, right at the center is magnesium. And so we're going to pick out of that list of all of those dozens of nutrients, and if we really want to start looking at all the phytonutrients and everything, there's hundreds and even thousands of nutrients in these green leaves. We're going to look at just one of those and see how essential it is to the body, why we need it, what's going on there, and understand its place in nutrition here. We're going to look at this magnesium. Well, of course, if there's enough magnesium to make every leaf green, how much magnesium is there in a green leaf? Well, a lot. And it's essential for the life of plants, but it's essential for our life as well. And one of the things we find when we start looking, according to the government's calculations of how much magnesium we really should have, 75% of the U.S. population does not consume adequate magnesium every day. Okay. Now we can say, well, how similar is our diet to everyone else's? But 75% of the people in America, so depending on how similar your diet is to everyone else's, do you fall in that 75% that did not get enough magnesium? And then even of those who do, how many are depleting the magnesium? There's a number of processes, we'll tell you, that actually severely deplete the magnesium in the body. So where is the magnesium in your body? Well, it's inside every cell of your body. All of the various enzymes, the various processes, and the nucleus of the cell, out in the cytoplasm, everything here, there's magnesium used all over the place there, and we'll look at it and some of the problems with it. When the doctors want to order a magnesium, what they call a serum magnesium level, the doctor draws a blood sample, they measure the amount of magnesium in the serum, that's the blood minus the blood cells, that clear yellow part of the blood. How much magnesium is there? Only 0.3% of your body's magnesium is in the serum. The other 99.7% is out in the cells here. The significance of that is, do not count on a blood test to tell you if you're magnesium deficient. You're looking at 0.3% of your body's magnesium and deciding on that level whether you're deficient or not. And that's what most physicians mistakenly use. What we really want to know is total body magnesium level. We can actually become quite depleted. We can be 10% low, 20%. We can be significantly depleted in magnesium out here and still dump enough into the serum that the level there is okay. So the magnesium deficiencies are largely hidden from people who are looking at blood tests to find them. So what are they doing in the cells? There are over 300 enzymes that need magnesium to work properly. What are enzymes? Enzymes are large chemical protein molecules that carry on chemical reactions. They make chemical bonds, they break chemical bonds. Life is a chemical reaction, and that chemical reaction is controlled by enzymes. And the whole purpose of the DNA that makes you who you are is the code to make enzymes. The whole purpose of DNA is the codes to make the right enzymes that make you who you are. And the purpose of the enzymes is to carry on the various chemical functions that make up your life. And a huge amount of those require magnesium. In other words, there are these amino acid chains that make this big protein, but right in what they call the active center, the part of it that carries on the chemical reaction, they often need something else to give them the perfect chemical properties to break a chemical bond or to make a chemical bond. And in the case of phosphates, phosphorus isn't free in the body. Phosphorus is always part of a phosphate with 4 oxygens bound in a tetrahedral around the phosphorus. This phosphate is used extensively throughout the body in energy and DNA and lots of places right here. And so there's a lot of things where we're building and adding on a phosphate or taking on a phosphate. And there's enzymes that do that, little chemical tools that will add a phosphate, take a phosphate off. For each specific thing, under certain circumstances, they'll do that. The body also uses adding a phosphate as a tool, as a switch to turn on one of these tools off or on. You know, you think of a machine right here, you kind of need an off-on switch. Well, putting a phosphate onto one will often activate it and make it start working away. Taking the phosphate off, it stops. And so you can turn it off or on by adding or taking. So there's another enzyme whose job is to add a phosphate or to take one off under certain, physiologic conditions. Complex how this all comes together, that God designed this amazing system. So which works. So all of these various enzymes, we know of over 300 of them so far, that work on phosphate, use magnesium, because magnesium have just the right electrical properties in their electron shell to pull out those oxygens around the phosphate, destabilizing it so we can either use it to create a new bond onto something else, or we can use it to break a bond and separate it from it. So all of the things that use that, we use them in energy and in DNA. You recognize the DNA, the double helix? All these crossbars are the various molecules that carry the code to build all the proteins. But what about this backbone that hides all of the, you might say, the letters in the code together? You know what it's made out of? Phosphates. There's phosphate bonds. This is just a ring of phosphate bonds, phosphate binding it together, because it's one of the strongest bonds, chemical bonds you can have in there. It's a very strong, it doesn't break. You don't want your DNA breaking. It's huge. It's several meters long, wound up into every cell so small it takes a microscope to see it. And yet we have to be able to unwind it and use it and read the right part of the code at the right time. But you don't want that strand to break. With all of its winding and unwinding it being used, if you break it, you've ruined it. You've broken the code. You can't go on. And so God designed these with very strong bonds. They don't break. But now to handle them, we need enzymes that can handle those strong bonds. And so all of your enzymes that are used to replicate DNA need magnesium in them. All of the ones that use the DNA to code for the messenger RNA, which takes the code out to the ribosome, which actually builds the protein, all of that RNA also has that same phosphate. So everything that handles RNA needs magnesium. So you start to realize that magnesium is extremely essential for life. Every dividing cell in your body, every time you grow a new skin cell, new cell inside your mucous membrane, you needed magnesium there to make all of this stuff work right. It's very, very essential for life. ATP, adenosine triphosphate. This is the form in which energy is transformed throughout a cell. And you'll notice that even the ATP doesn't float around free. You'll notice here there's actually a magnesium ion that chelates on here. Here's a magnesium ion chelate here in a different spot on the molecule. These energy molecules need the magnesium so that the right properties, they float around to be used by all the other molecules. Every bit of energy in your body needs magnesium. Think about the implications of being a little bit deficient and having not enough magnesium here. None of these things are going to work right if they're not, really just bathed in a solution of magnesium here to make them run right here. One more illustration just to help you get the picture right here. This chemical reaction, starting up here with glucose, going down this chain of reaction. These are all the enzymes working on glucose to break it down to the level of pyruvate. This is just anaerobic metabolism here. This is just breaking the first step in breaking down glucose. This pyruvate is what then goes inside the mitochondria through the Krebs cycle, the citric acid cycle, where you pull out even more energy there. But I just pulled off this one piece of it here so you can get a look at it. Each of these little steps requires an enzyme. And look, if you can see here, see that little green magnesium right there that's drawn in? This enzyme has to have magnesium to work. And here, this enzyme right here needs magnesium to work. This enzyme right here needs magnesium to work. This one right here needs magnesium to work. This one here needs magnesium to work. This one here needs... Do you see how essential magnesium is for all these chemical reactions of life? Very, very essential. Everything doesn't work right without it. So what starts happening if we're deficient, if we don't have enough of this? One of the things that magnesium is essential for is proper muscle action. Whether we're talking about skeletal muscle, smooth muscle, or that very important muscle in the center of your chest, your heart. If we're deficient in magnesium, there's going to be some problems there. People with congestive heart failure, if their magnesium levels are low, that congestive heart failure is going to be worse. The heart is not going to function as well as it should. And closely related to that, cardiomyopathy. A magnesium deficiency can actually of itself, if it gets low enough, give you a cardiomyopathy where the heart is just not functioning like it should. It's not doing its job. And it can certainly worsen any other type of cardiomyopathy. If your magnesium level is not up where it should be, the heart is not going to be getting the proper output it should be. But it's not just the cardiac muscle itself. The heart has coronary arteries. And these arteries have smooth muscle in the wall. And if you don't have the right amount of magnesium for those muscles to work properly, they can actually go into something we call coronary vasospasm, a constriction down that can be very detrimental, causing acute chest pain or even an acute heart attack. Not all heart attacks are caused by atherosclerosis and high cholesterol levels. A certain percentage of them fall into this area of acute vasospasm reactions here. And of course, the electrical activity of the heart requires magnesium to have the right electrical balance for all of its electrical activity there. And many cardiac arrhythmias are caused by magnesium deficiencies and corrected by it. In the emergency part, when someone comes in with a heart attack, acute myocardial thing, or some cardiac arrhythmia, frequently we in the ER or the cardiologist will give them an infusion of magnesium to try to stabilize things out, to try to improve the cardiac output, to try to reduce the arrhythmias that are going on. So in addition to the other interventions, magnesium, the role is recognized there, and we realize you've got to have magnesium for that to work right. High blood pressure. Again, the smooth muscle that makes up the artery walls there, there's calcium and magnesium sort of in balance here. They sort of have opposite effects. And if you don't have enough magnesium, we can get spasming, tightening. We mentioned there in the heart the spasm, but the spasming, then they're not getting the proper relaxation, and it will contribute to high blood pressure if there's not enough magnesium here in the diet. You know, a lot of people suffer from that. And of course, what's the first thing the doctor does? Oh, have some more spinach? Well, even with high blood pressure, did the doctor tell you to eat spinach? What did he give you? Some pills, right? And what's the number one most common pill? Hydrochlorothiazide, a diuretic, is the number one. First line, they're going to start you out there. After 25 doesn't work, they go up to 50 milligrams, and then we start adding others. And there are probably more pills given for high blood pressure than for any other condition. There's just so many different ones. We try to create the lower blood pressure without actually treating the cause. By the way, did you know no pill given for high blood pressure treats the cause of high blood pressure? No. They're all just trying to manipulate the physiology so that the blood pressure cuffs, so that we're running a lower pressure here. None of them are doing anything about the underlying causes. The underlying causes are all dietary in nature, whether we're talking about atherosclerosis and hardening of the arteries, whether we're talking about magnesium deficiencies and so on. They're all metabolic. None of them are corrected with the pills right here. Did you realize that hydrochlorothiazide is worse than any other medication at depleting the body of magnesium? So here we've got a condition that magnesium deficiency makes worse, and so we give them a pill that is known to deplete magnesium from the body more than any other medication. Yeah. Hydrochlorothiazide, it works on the kidneys and causes the kidneys to dump huge amounts of magnesium out in the urine there. All the other diuretics also do to some degree. So any of the water pills or diuretic pills, you're dumping magnesium out in your urine. So no matter how much you're putting in the diet, if you're taking one of these pills, you're messing up the machinery the way God made it, and you're losing this magnesium out of the body. There are many other classes too. You can Google it and look for medications that lower magnesium, and you'll find it's just a huge list of medicines. You can see if any of yours are on that there. Yeah, someone's got to stand up and say it. The answer is not another pill. The answer is spinach. We got to go that right here. Diabetes. Oh, diabetics, universally found to be low in magnesium. And indeed, they found you can improve diabetes, improve blood sugar control, improve insulin resistance with magnesium supplementation there. Of course, better than a pill, some kale. Fibromyalgia. Clinical studies show magnesium supplementation can reduce the pain, the tenderness associated with fibromyalgia. Muscle cramps and spasms. Magnesium, again, we're talking about the effect on muscles. You need this proper balance. And when there's not enough magnesium, it's easy, whether it's a coronary going into vasospasm, your calf muscle going in. If you suffer from muscle spasms of some kinds, consider it may be a sign your body's telling you, we don't have enough magnesium in here. It's time to go out and plant a garden and start eating it. There's your answer. Magnesium in the brain. We've talked about muscles, but the electrical activity of brain, of synapses, magnesium is very important there. Again, in balance with calcium. This calcium-magnesium balance working with opposite effects right there. Absolutely essential for it to work properly. And without enough magnesium, the brain is not working right. They've done an amount of research on insomnia. How many people suffer with insomnia? I mean, not being able to get enough sleep affects everything on your brain for the next day. Magnesium is essential for the normal physiology of sleep to occur. Good magnesium levels are supplementing up. If you've got bad levels, helps you to fall asleep. It helps you to stay asleep. We found that it restores those deep wave patterns. When you go to sleep, the brain has this kind of waves, and then it goes into a deeper level of sleep with a different kind of wave, and then there's about 4 levels of sleep here, each with different kind of waves, and it's this really deep sleep where real restoration, growth, and healing to the body and the brain takes place. And most people don't get down to that level. Caffeine is one of the things that blocks us from getting to that level. But not having enough magnesium blocks that. If you don't have enough magnesium, you're not going to be able to get down to those levels and not get the restoration you need from your sleep. If you've got restless leg syndrome keeping you awake, magnesium works on those spasms, can reduce that there. And many people find just by putting they're getting their total body magnesium levels up where they should be, completely restores their insomnia problems. If it wasn't a drug-caused problem. A lot of us, I think most insomnia problems are drug-related issues. We're on so many medications, drugs, not to mention caffeine and some of that, we've got sleep issues related to those. But here, insomnia. Memory and learning. Huge amount of research has gone on in just the last few years on the effects of magnesium supplementation to enhance learning. You take these rats and they put them on magnesium, and suddenly, wow, they can remember these mazes 10 times better. And they're starting to realize they're doing human experiments. They find out, wow, magnesium and people's brain works better. You can remember things, memorize things. All this stuff works better on magnesium. Most of them, experiments are using this magnesium L-threonate. It's magnesium just chelated to an amino acid that your body normally uses, needs anyway. Tends to cross the blood-brain barrier a little better. Of course, I'm not really recommending run out and buy this particular magnesium supplement. What am I recommending? Eat the greens, yes. The same thing God said when they left the garden. I'm giving you these greens, eat your greens too. And you need the greens out there in that world. Eclampsia, emergency condition in the last trimester of pregnancy. If you come into the ER, the one thing that we can do for eclampsia to try to save the baby in pregnancy is we give them an infusion of magnesium. We'll give them multiple infusions and trying to reverse it. If we're unable to do it with that, they have to rush them in and actually do emergency C-section, even a premature one. So magnesium definitely there in pregnancy is a needed substance. And, if you're growing a new baby, just think of everything the baby needs magnesium for. Definitely something you need there. In my emergency room, asthma, bad asthma, something I see almost every day. When they get in there, besides getting them on some oxygen and some nebulizers to try to reduce the bronchospasm there, what's one thing I give to every asthmatic? Plug in an IV and give them a couple of grams of magnesium sulfate. Why? Because we found out that it helps to relax where their lungs are in that asthmatic spasm there. Indeed, we find that low levels of magnesium are associated with an increased risk of developing asthma, either in adults or in children. Again, we live in a world where everybody is deficient, and we see a huge increase in all these diseases that are associated with magnesium deficiency. Do you know 60% of the magnesium in your body is in your bones? Just like most of your calcium's in your bones? Yeah, it's a story. Your bones are not just made out of calcium. They're made out of calcium and magnesium there. And as we mentioned before, 75% of Americans don't get enough. And even those do, there are things that deplete it. And so we're going to take a brief look at those things that will deplete your body of magnesium. And number one on that list is sodas. And I'm talking about phosphoric acid. I'm talking about caffeinated or uncaffeinated. Root beer, 7-Up, yeah, they're full of phosphoric acid. And those phosphates, remember back when we talked about enzymes, how magnesium and phosphate have that real affinity? Well, these phosphates, they bind up all your magnesium and prevent you from absorbing it. So you can have this beautiful green salad full of baby spinach and all these dark greens, and then to finish off your meal, you have a root beer. What happened to all that magnesium in your salad? Oh, that phosphoric acid just bound it all up, and sorry, you don't get any. Okay, so sodas is one of the culprits here. Really something we should eliminate from our diet if we want to be healthy. Stomach acid. You've got to have good stomach acid to release the magnesium. If you understand some of the general chemistry principles of ions and ionization, you realize you need this acidic environment to separate out, to release the magnesium and make it available. Of course, today, one of the best-selling drugs are the acid blockers. And used to be they were prescription drugs. But now they've made virtually all of them over the counter. You can go in and get as much as you want. And surprised at how many people are on these on a regular daily basis. Every day they're taking these acid blocking drugs. Of course, what's that doing to all the magnesium in the greens they're drinking? Yeah, we're blocking the magnesium absorption here again. Calcium supplements. Everybody knows we need more calcium, right? Wrong. We got a problem here. You see, calcium and magnesium, as I mentioned, the body, they're often in balance. They're similar in many ways in some of their electrical and size probably stuff. And the way God designed it in your gut, by the way, things don't just diffuse and absorb from your intestines into your blood. There's active little enzymes whose job is to pick certain nutrients and put them in. And their absorbing is a very active process that takes energy, and they're using it. Well, to get in calcium or magnesium, there's this little receptor tool that grabs the calcium from your gut and takes and moves it inside of the gut lining. And it grabs the magnesium. And the way God designed it, the same tool works for both. So this tool grabs magnesium or calcium. Now, in a balanced diet, you'd have a balanced amount of both and no problem. But when you start taking calcium supplements, suddenly what's happening? We're flooding the gut with an overabundance of calcium. And what's that do to all these calcium receptors? They're all bound up with calcium. They're busy taking, because every time they reach out for another molecule, it's a calcium, another calcium. Why isn't there any magnesium? There's more calcium. They never get around to the magnesium, right? Because it's so few compared to that. And so you're really depleting your absorption of magnesium with the calcium supplement. And doctors and scientists realize this now, and most people are recommending if you're going to take a calcium supplement, it should be a magnesium and calcium supplement, and have both in there, either in 2-to-1, or some people are even recommending 1-to-1 now, and the proportions there in a supplement. Of course, what's the ideal calcium supplement? Remember back on our list on the beet greens, how much calcium was in it? Huge amount of calcium in there, yeah. See, God knew you needed calcium and magnesium in balance, right? So he put them in balance in the greens, says eat the greens, and you're going to get all the calcium and magnesium you need right here in these dark greens. Of course, we can't miss caffeine here. A cup of coffee has what properties? It's a diuretic. And like the hydrochlorothiazide and the other diuretics, it causes the kidneys to just pour out magnesium into the urine. So even if you've had some good supply of greens today, that Dr. Pepper you had after lunch is going to, it's going to dump all that extra magnesium out in the urine instead of letting it go into the cells so that you can use it for the important life functions you need it for. And empty calories. Adventists that stay away from other bad things tend to not realize this is a health problem right here. But refined sugars and white flour not only have no magnesium in them, 0 magnesium in sugar, 0 magnesium in white flour, right? They're total non-magnesium sources here. But all of that sugar, when it goes to the cells to be processed, how much magnesium does it take to process it? You're using up a huge amount of magnesium to do all of this processing. And to process all of the refined sugars and refined carbohydrates here, we are using up a lot of magnesium. So the net effect is not 0. The net effect is negative. They're really anti-nutrients. And a diet that has a significant amount of the empty calories here is really a magnesium-depleting diet. So again, goes a long ways to undo all of the greens in the diet there. And the last depleter we'll mention right here is the stress hormones, epinephrine and cortisol, released by the adrenal gland. Both of these come from different parts of the adrenal gland. When we're under stress, whether it's an immediate stress that you're in a near-miss automobile accident, or your body's under physical stress, you got a terrible burn, or whatever the physical stress or emotional stress that's hitting you, your body is releasing a huge amount of epinephrine and cortisol. And these are depleting of the body. So are the chronic stresses, anxiety. If you're living in a constant, anxiety state of one degree or another, or fear, resentment, and that big one for the human race, guilt. All of these are causing the kidneys to dump magnesium. Now, if you start to think about what we're talking about there, going back to when Adam and Eve were driven out of the garden, and God said to them, "Eat the green leaves." Something had changed in the human race from Adam and Eve before the fall. Sin had brought in an element of stress. Fear, anxiety, resentment, guilt were not part of Adam and Eve's experience before they left the garden. But now God was sending them out into the world, and for the next 6,000 years, those were going to be the universal lot of the human race, those emotions, those stresses. And way back then, God realized those are powerful magnesium-depleting stresses. If you're under stress, you're depleting yourself. And God said, hey, look here. Eat the green leaves. We got to restore that. We need to make that back up. Your health is not going to be as good out here with guilt and worry and anxiety and stress and fear. And, the life just goes on. And life is one round of that. Even a good Christian life ends up with a lot of stressors in it, doesn't it? Yeah. Did Jesus face stress when he was here? Yeah. Probably a lot less than others that did not have as much faith in God. God's given some powerful things to combat stress, hasn't he? And of course, that most powerful of all is what? Trusting the Heavenly Father. You look at, I always like the story of when the disciples were out in the boat and the terrible storm comes up and the boat is about to sink and the disciples are doing everything they can to keep the boat from sinking and they're losing the battle. Where's Jesus? He was sound asleep. He had a good magnesium level, right? He had faith and trust in his Father. He wasn't dumping magnesium for a lack of faith and trust. Now, if you drew a blood sample on Peter and a blood sample on Jesus after their boat came to land that day, you think you'd find a difference? If you measured the adrenaline levels in Peter and the adrenaline levels in Jesus, you think there's a difference? You think there would have been a difference if we checked their magnesium levels? Maybe not, because it's not in the serum, right? It's not in the tissues. But you get my point. Trusting God can also help to restore these right here. But as we went out in the world, God gave us this, shall eat the green herb of the field. And today there's lots of ways we can have salads and we can steam up the greens and make green smoothies. God's made a lot of ways for us to take this in. So I hope that one thing, if we had a educational objective here, at the end of this, we will see the value of and eat more greens with every meal and every day, right? Did I make my point? Are you all going to eat more greens now?